Welcome to IGCSE Computer Science, and today we are going to continue our chapter number 3. In chapter number 3, we are discussing about the von Neumann architecture, and we are learning the central processing components. In the last lesson, we have discussed about the ALU and the control unit. Today, we are going to continue system clock. So what is system clock? As we know, the concept of a clock is to calculate what? Calculate time, right? So
Yeah.
the system clock is definitely used for the same purpose. And it is going to produce the timing signals on the control bus to ensure the vital synchronization takes place. So system clock is producing the signals on the control bus. Do you remember we have 3 types of buses: address bus, data bus, and control bus. So you see here, this is our control bus. So you see the system clock is here. It is going to send the timing signals, and that timing signals are going to be sent with the help of control bus.
Okay.
So without the clock, the computer would simply crash. Yes. Clock is there
Yes.
to manage the timeline. Clock is there to manage the timing signal. Clock is there to estimate the sending and receiving of files or data. But if the system clock gets failure due to any reason, your system would simply crash or being restart again and again. So the RAM holds all the data and programs needed to be accessed by the CPU. The RAM is often referred as immediate access store. So we have a new name of RAM. As you know, what is RAM? Random access memory, right?
Yes.
So RAM have a new name. What is the new name?
Immediate access store.
Very good. Immediate access store. So this is a new name of a RAM. So RAM, what is the purpose of RAM? Do you know?
The purpose of RAM, I think it's to store memory, but not it's just the temporary purposes.
RAM is there to manage the programs, what we are using in the computer. Like right now, I'm using Microsoft Word. Right now, I'm using Acrobat Reader, Zoom, WhatsApp. Many applications are there. These all applications are stored where? These all applications are stored in RAM, right? So RAM takes the data which are currently in use, but your answer is right. It takes the data on a temporary basis. So the CPU takes the data, programs held in backing storage, and puts them into the RAM. Yes. So we have a CPU. RAM is a part of our CPU, right? So CPU takes the program from where? From our hard drive. Look, whatever we download, it is always stored where? It is always stored in RAM, sorry, hard drive. Like you have downloaded a movie. That movie is downloaded in your D partition or C partition. So that is in your hard drive. But once you double click on your movie to watch, that movie is going to be sent from your hard drive to the RAM. So when you are watching the movie, the RAM supports your movie. But once you cancel or close the movie, it will be deleted from RAM. So whatever the data is stored in a hard drive, that is a permanent data. But that data is going to be sent where? Into RAM.
Yeah.
Right? Into RAM. Okay, so what happens? This is done because the read-write operations carried out using the RAM are considerably faster than read-write operation to the backing storage. Yes, why? The CPU send the data into RAM. What is the reason? The reason is RAM is faster. RAM is faster in processing and executing the instructions, but hard drive is slower than RAM. That is the reason the programs are taken from computer or from the computer hard drive into the RAM for processing. Why? Because RAM is faster. So what happened?
Okay.
Consequently, any key data needed by an application which is stored temporarily in RAM to considerably speed of operations. Yes. So when you wanted to use any program, you double click on it from hard drive to RAM. It is being transported. Why? Because we need a speed. We need a faster computing. So the RAM will play the program for some time. So this is all done. This is all done with the help of a RAM, and there is a system clock who is going to maintain the timing signal. Any confusion?
Okay. No.
Okay, have you written down the notes for ALU and CU?
Yeah, I sent it to you.
Perfect. Okay, now you have to write down about system clock and RAM. For both, you need to write down points, okay? And send me the picture in the group. The topic is registers. So you see the registers all the way here in this one human architecture. And definitely you think that these 5 registers are here. And what is the purpose of registers? Like, as I told you, registers are used to store the data. But they are also storing the data temporarily. So just like RAM, registers are also storing the data on a temporary basis, but definitely there must be a difference between RAM and registers. So we have how many registers? 5 registers. The registers are MAR, TC, MDR, CIR, and ACC. Every register have a different feature. Let's see how it works. One of the most fundamental component of the von Neumann systems are registers. Registers can be general or special purpose. We only consider the special purpose register. A full list of registers used in this textbooks are summarized in table 3.1. So here is a table 3.1, and you see some specific purpose registers. I told you, what are registers? Registers are the temporary memory which stores our data. Instructions, you can say. Are you getting it?
Yes.
Do you remember in chapter number 1, conversions? I draw the boxes.
Yes.
And I always say, what are they? They are
Yeah.
registers.
Registers.
I always said
Yeah.
that draw the register pattern, register. Why? Because it's holding our bits. It holdings our bit. So the bit holding is a temporary process for this purpose, and the registers are there which are going to store that bits. So how many registers we have? We have 5 registers. Let's say the number 1 is CIR, current instruction register. This register stores the current instruction being decoded and executed. Okay, let's suppose I'm going to write, here we go. I'm going to write computer science is exciting, right? This is my instruction. Now, this instruction I have just entered, and this instruction is stored where? In CIR. In CIR, what is the next thing you see here? Instruction being decoded and executed. What does that mean? Let me tell you. In CIR, the instruction is being decoded like this. Like this. And then it is processed to CPU, because a computer is able to read zeros and ones. They are not able to read the English language. Did you understand it or not?
Yes, I did.
So CIR is going to take your instructions, stores instruction, and execute it. Now, there is another register called ACC, accumulator. This register is used when carrying out ALU calculation. Do you remember the working of ALU?
Yes.
Responsible for what?
arithmetic
Very good.
calculations.
Whatever the calculations you're performing in an ALU unit is going to be stored where? In accumulator register. So accumulator is a particularly designed register to store all the calculations. And yes, it is also a temporary calculation area. Any confusion?
Okay. No.
Next is memory address register, that is called MAR. This register stores the address of the memory location currently being read or written to. What does it mean? Let's suppose there is a register. Okay, it stores the address. What do you mean by address? This is a data, like I'm writing ABC. This is my data. Definitely data is stored somewhere in the memory. So the place where it is stored in the memory having an address. This is the thing called address. Just like you. If I'm going to ask you, what is your address? You said, sir, I live in Kolkata. I'm living in Bangalore, number 45, street number 3, blah, 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 right? This is your address where you resided. Is that okay? So,
Yes.
just like your address, every data have an address in the memory. But that time, the address is not like your address. The address is always in a form of ones and zeros. So can you tell me what is the address here? 1011. This is the address, right?
Yeah.
This is a memory location. You can say memory
Yes.
location as well. I'm just writing ADD here
Okay.
for you. Okay, this is a memory location. Okay, so what is the purpose of MAR? What is the purpose of MAR? Memory address register. This register stores the address of the memory. So this 1011 is going to be stored where? In MAR. What is the full form of MAR?
Memory address register.
So is it going to store this address? Look, this is the job of MAR. So whatever the data you're written, what data you're written? ABC. That data is going to be currently written in 1011. So that is being executed. Now, what is the next address register? MDR, memory data register. So what is the meaning of memory data? Look, what is the data you have saved here? Tell me. In the register 1011. What is the data? Yeah. ABC. This ABC data is stored where? In MDR. Yes. So data is stored in MDR and the memory location is stored in MAR. Is that okay?
Yes.
So MDR stores the data, right? You see here, this registers store the data which has been read from the memory or data which is about to written to memory. So you're writing ABC. That ABC is a data that is transported to MDR. 1011 is the address of the location. That location is stored by MAR. And finally, program PC, it stores the addresses where the next instruction to be read. So let's suppose I have written computer science is exciting. This is my instruction. This instruction is stored. Let's suppose in a memory location 1010. So this is my next instruction. So after this instruction 1011, what is my next instruction? 1010. This is the address actually. This is the address actually. So the PC is going to load this address into the register or stores the registers. So look, the PC stores this register's address where the next instruction can be read. So after 1011, let's suppose we have 1010. So the next instruction is going to be stored in PC, program counter.
Okay.
Okay, so take out your notebook, write down about registers. First, I want a proper introduction. Then I want a proper name with the full form and their purpose. Take your time, no rush.
Okay. Yes.
Let's discuss that system bus and the memory. So we have three types of buses, you know that. Address bus, data bus, and control bus. So let's see about the buses. The address bus carries the address, but not the data. So you have to understand. You have to understand this thing. Here I teach you 1011 is the address. And what is the data? ABC. So the address bus takes
Yeah.
address, not the data. The data is ABC, right? Okay.
Yes.
It is going to circulate the addresses between where? Between the memory unit and the CPU. So here in this diagram, you see the address bus is here. And it is going to take the data, look, from the CPU. You can see there is a one-way arrow and pass this data where? To the ports and where? To the memory unit. You see here. Did you get it?
Okay.
So in
Yes.
simple, the address bus is going to send the addresses, carry the addresses between the memory and the CPU. Now we have data bus. So you know that the data bus, of course, carries the data between the processor and the memory unit. And of course, it is also going to take the data from the input and output devices. Like if you're taking the keyboard, monitor, mouse, and you're passing the data to the printer, so the data bus will be used. And the control bus, of
Okay.
course, carries instructions from the CPU to control the action of the computer. So control bus is the most responsible bus. It is the most powerful bus, which is going to control the instructions. Whatever the data is circulated into the CPU, the control bus always taking that data. Now we have a
Okay.
detailed topic on buses. So we know about the buses. A buses used in a computers as a parallel transmission, and each wire in the bus transmits one bit of data. So this is a detail. Basically, buses are the wires. Look, they are the wires. And in that wires, the data is going to be transported one bit at a time, like this. So first, I'm going to discuss address bus. The address bus carries addresses throughout the computer system. The address bus is unidirectional. What do you mean by unidirectional? You see here in this figure that a single arrow was just here. You see this arrow? And then you see this arrow, and you see this arrow. So you see the address bus only receiving the data. It is not sending data back like control bus. See this control bus arrow, it is receiving the data and it is sending the data back. But in address bus, you are just receiving the data. So it means it is unidirectional. It means the data is only going to be received by address bus, not able to send the data back to the component. This type of a bus is called unidirectional.
Okay.
Okay. So did you get the idea of unidirectional?
Yes.
So bits can travel only in one direction. So this prevents
Yes.
addresses being carried back to the CPU, which would be an undesirable feature. Yes, we don't want addresses back to the CPU. Why? There's no point to sending the addresses back because we're sending the data with the addresses. So definitely the address bus is always there to carry the addresses to the different parts of the CPU. So one more thing is very important. The width of a bus is very important. The wider the bus, the more locations can be directly addressed. So wide, it means the size of the bus. If the size of a bus is wide, you see here. So more and more data can be sent. And if the width of the bus is not wide, like this, look, So less data will be sent. Do you understand this logic? Width.
Yes.
Width means the broad. If you have a broad width of a bus, the bus can send more data. And if the size of the bus is not wider, it means the less data will be sent, right? So a bus of width 16 bits can address 2 power 16 memory location. So if you are using a bus with the 16 bits, how many? 16 bits. So the computer would take that as 2 power 16. So what will be the available addresses? 65,536 memory addresses. And if you are using a bus with a width of 32 bits, so 2 power 32, it will become 42 billion 94 million something addresses. So it means the wider the bus, the more and more data will be transported. Is that okay?
Yes.
That's great. Now, what is the next type of a bus? Data bus. The data bus is bi-directional, allowing the data to be sent in both directions along the bus. What is bi-directional?
It goes both ways.
Very good. So the data bus carries data, right? From the CPU to the memory and into the input and output devices. It is important to point out that the data can be an address, an instruction, or a numerical value. Yes, data can be anything. Data can be anything. Either it is an alphabet, either it is a numeric value, or either it is any special character or string. It is a data. So the data bus have a job to transport the data to their places. So the width of the data bus is important. Again, the same thing width. So I teach already. Width means the wider the width, the more data can be transported. And the control bus is also bi-directional. It carries signal from the CU to all other computer components. Yes, control bus. I told you it is very responsible. So the control bus is going to take the signals. It is a bi-directional. It can send the data. It can receive the data, and it is going to send the data to throughout the part of the control unit, right? So it is usually 8 bits width. So the width of the control bus is 8 bits. So you can write 2 power 8. So you come to know how many addresses can be sent. So there is no real need for it to be any wider since it only carries control signals. Yes, it is not going to send or receive the data. It is just going to send and receive the signals. So I think 8 bits wider is enough. It is enough. Any confusion?
No, sir.
So kindly, first you need to write down about the buses. First, you need to draw this diagram. This is more understandable. As you see, it's showing the sending and receiving of bits. So it is much easier to understand from this. Once you